Hello and welcome again to the MathTablet. In this session we're continuing with our series on factorization. This time we're having a look at what's called trinomial factorization. Okay? Now there are times when you have an expression like x squared minus 6x plus 5 and you're trying to factorize it. Notice that there is no common factor across all three terms. At the same time, it can't be a difference of two squares. Well, for starters, there's three terms. If it's difference of two squares, it's got to be two terms. Okay, and there's certainly no square numbers within that. So, by process of elimination, it wouldn't be a common factor factorization. It also wouldn't be a difference of two squares factorization. This is a situation where it's called a trinomial factorization. Okay, so what we're going to do is to reverse the expansion idea. Okay, we're going to introduce two brackets. You know from your expansion, by multiplying out those two brackets, you will end up with three terms. That's why it's called trinomial factorization. Now, to get your terms in the brackets, have a look at that first term. In order to get the x squared, I would have to have an x at the start of each of my brackets, okay? Because the beginning part of the factorization would involve me multiplying those two terms together. That's where the x squared would come from. Now, the other two terms within the brackets is found by the number on the end as well as that coefficient of x in the second term. So basically, if we were to hone in on this number on the end there, okay? Now what I need would be two numbers that multiply to give me positive 5, and those same two numbers need to add to give me negative 6. So the fact that they have to multiply to give me positive 5, but then they have to add to give me a negative number would suggest that they're both negative. Okay, so thinking of the factors of 5 is really only 1 and 5. So let's try negative 1 and negative 5. Let's see. Negative 1 times negative 5, yes, they will multiply to give me positive 5. And negative 1 plus negative 5 is going to give me negative 6. So that combination works, which means my brackets will have negative 1 in one of them and negative 5 in the other. We always check just by expansion. So, as I mentioned before, x times x, that's where the x squared will come from. Then I'm going to have negative 5x, take x, plus 5. Let's just check. That's going to be x squared, take 6x, plus 5. So I know that that is the correct factorization. Okay. Let's try another example. Something like, let's see, maybe x squared minus 4x minus 77. So again, looking at that, it can't be a common factor factorization because there are no common factors. It also can't be a difference of two squares because there are no square numbers and there are three terms. So this will be a trinomial factorization. So introduce your two brackets. In order to get the x squared, I have to have an x at the start of each of my brackets. Now looking at those numbers. Okay. So this time, my two numbers need to multiply to give me negative 77, and they have to add to give me negative 4. Okay. Now, given that they have to multiply to give me a negative number, one number would have to be positive and one number would have to be negative. So thinking of the factors of, say, 77, the obvious one would be 11 and 7. So let's try negative 11 and 7. They certainly multiply to give me negative 77. And negative 11 plus 7 will give me negative 4, so that fits both of those criteria. Okay. In the event where you tried, say, -7 and +11, alright, they would certainly multiply to give me -77, but they would add to give me +4, so that one doesn't fit, right? So in that event, usually what we would just do is to try the other combination by having the sign switched around on the two numbers. Okay, so in this case we've got -11 as well as +7 to complete my factorization. So again, let's just check. That's going to give me x squared plus 7x plus -11x, which is going to give me the -4x, and then take 77, so I know that that's going to be a correct factorization. Let's try one more, a harder one this time. Okay, so we've got, in this case, I'm going to try 2x squared minus 22x plus 48. Right? Now, this one is harder because notice that the coefficient of x squared here is 2. All the ones that we have done before had a coefficient of 1. Okay? Now, you've got a coefficient here of 2. So, when you've got that, check the other numbers. Notice that you've actually got a common factor here running through all three terms. So, this is going to have a highest common factor of 2. So what we're going to do in a situation like this is to take the 2 out first of all the terms. So you're left with x squared minus 11x plus 24. Okay. Now this is a partial factorization because we've taken out the highest common factor there of 2. But within the brackets there, I now have a trinomial factorization. So leave the 2 where it is and introduce your 2 brackets. Okay, so we pretend that 2 is not there for a moment. To get the x squared, I need to have an x and an x. Now I need to have the numbers multiplying to give me positive 24, and I have to add to give me negative 11. Okay, so thinking through the combinations there, let's see, 8 and 3 would seem to fit the bill, right? 8 times 3 will certainly give me 24, but I need them to add to give me negative 11. So what I'm going to do is to make them -8 and -3, because 2 negatives will certainly multiply to give me a positive 24 there, and they will add to give me the negative 11. So let's just put those in. So -8 and -3 would fit. Okay, now this final expression would be a fully factorized expression. I hope you've enjoyed this session of the MathTablet.